So let's jump to number 5. It says, find the vertex, the equation of the axis of symmetry, and the y-intercept of each function. Okay, they ask us for several things. Let's first start with the vertex, the most important thing. All right, so how are we going to find the vertex? You're going to use x equals negative b over 2 times a. And of course, we're going to use parentheses. And in order to identify the a, the b, and the c, the a is the first term, or the coefficient of the first term in standard form. The b is the 4, and the c is the 6. Anyhow, let's plug in 4 for b and 1 for a. So we're going to get negative 4 over 2, which means that the vertex x value is negative 2. Now, if you want the y value, all you got to do is plug it in. So I'm going to rewrite it with parentheses instead of the variable x. And of course, we are plugging in a negative 2 right in there. And when we work this out, negative 2 squared, that's 4. And 4 times negative 2 is negative 8. So we really have a positive 4 minus 8 plus 6. So that's really going to be negative 4, because 4 take away it's negative 4, plus 6. The answer is positive 2. So the vertex is negative 2, positive 2. Okay? That's the first thing they ask for. What else do they ask for on the instructions? So the second thing that they ask for is the axis of symmetry. Now, drawing the axis of symmetry on a parabola is easy because you just draw the vertical line right through the vertex. Stating the equation of the axis of symmetry is really easy also, because it's simply x equals the x value of your vertex. So what's the x value of your vertex? What's the x value of your vertex, guys? Negative 2. So guess what? That is the equation of the axis of symmetry. If you were to draw that, x equals negative 2, that would be the vertical line crossing right through the vertex. And they also asked for the y-intercept. So let's keep this in mind. To find the y-intercept, set x equal to 0 and solve. And we all know that that's the easiest number to plug in. So if you plug in 0, your output will be the c value 6. Right? Plug in a 0 here and a 0 there. It'll all be 0 plus 6 is 6. So to find the y-intercept, the coordinate where the parabola will cross the y-axis, plug in 0 for x, and you get the c value 6 for y. And that's the location of where your parabola will cross the y-axis. Those are the 3 things that this section asks for. I hope you guys understand it. Let's move on. Down here, we have multiple part questions, 7, 8, and 9. We have A, B, and C to each one. So let me go with, I'll do 8. It says determine whether the function has a maximum or minimum value. Okay, and then it says state the maximum or minimum value. And then what is the domain and range of the function? Well, all of that could be done by finding the vertex, because the vertex is the max or min. But stating the max or min is even easier. All you got to do is recognize whether the parabola opens up or down. So ladies and gentlemen, does this parabola open up or down? Up. Why is that? How do you know that it goes like that? Yeah, because the a value is positive, right? The a value is positive 1, the b value is negative 2, the c value is negative 5. So if you know that your a value is positive, you know it's going to open up. Now, what does that mean? If it does open up, it means that this is a lowest point, which is what we call a minimum value. So the first thing that they ask for, part A, says, is it a max or a min? We're going to say it's a min value. Why is it a min? Because the a value is positive, which means that it opens up, which means that you end up with a minimum value. Minimum value, right? So that's a min value. It also says state the minimum value. We all know that this point down here, this lowest point, is also known as the vertex. So let's find the vertex again. The vertex is a coordinate. We are plugging in the b value of negative 2 and the a value of 1. So you really have positive 2 over 2, which means that the x value is 1. So the vertex x value is 1. You want the y value, plug it back in. So if we do plug in a 1 right here and right here, We could do this in our head. 1 squared is 1. 2 times 1 is 2. So you really have 1 take away 2. That's negative 1. And negative 1 minus 5 is negative 6. So when I plug in a 1, I get out a negative 6. That's our vertex, which technically is the answer to part B on this section. The min value is the vertex, which is 1, negative 6. So that's your B answer right here to this question. The minimum value is the vertex 1, negative 6 in this case. What's the final thing that they ask for, part C? The domain and range. Okay, so we already know that this is opening up, and we already know that any parabola has the domain values x equals all real numbers, because it's going to go to the left and to the right forever. Even though it goes up, it never goes straight up. If you ever draw a parabola with lines that go straight up like this, then you know what? Technically that's wrong, okay? Because it never goes straight up. It always, even though it goes up, it continues to go out forever, okay? And it continues to go out forever. So it should never go straight up, okay? So anyways, the domain, x equals all real numbers, is always true for any parabola, whether it opens up or down. And now for the range, you're talking about the y values. So if we know that the parabola opens up, and we know that the minimum value is 1, negative 6. So if you're struggling with that, you could go ahead and make a quick sketch, right? 1, negative 1, 2, 3, 4, 5, 6 is way down here, right? And we know that it's opening up. Just a quick sketch. We don't even need an XY table, just a sketch. What do we know about the y values on this parabola? Is there any y values that are down here? No, they're all from here and above the y values, because the y's are going up and down. This whole parabola is all above this value. So if this is the minimum value, which is 1, negative 6, and it's all above that coordinate 1, negative 6, we're going to say that all of our y values are what? Above, which means greater than or equal to what? Negative 6. Ladies and gentlemen, we have answered everything that they asked for on this middle section, those 3 parts. Do you have a min or max? That's easy. Look at the a value. That'll tell you if it opens up or down. Then you could decide if it's a min or max from there. And then you could actually state the min or max value just by finding the vertex. And then after that, knowing the vertex, you'll have an idea of where your parabola is. And knowing the a value, whether it opens up or down, you'll know that if it's above a certain value or below a certain value. So the range is y is greater than or equal to negative 6. Let's jump to number 12. Number 12. Okay. Let's graph this thing. First step is to find the vertex. And we do that by using the formula negative b over 2 times a, which we're going to do negative parenthesis over 2 times parenthesis. And we're plugging in the b value, which happens to be negative 4. And the a value happens to be negative 2. So you really have a negative 4 on top, which is a positive 4 up on top, over a negative 4 on the bottom. So our vertex x value will be negative 1. Make sense? Okay, now let's take that negative 1 value, take this negative 1 value and plug it in into that x and into that x. That way we could work out the math and find the y value. So I am plugging in a negative 1 right in there and a negative 1 right in there. And let's work this out. We have negative 1 squared, that's positive 1. And positive 1 times negative 2 is negative 2. And then over here we have a negative 4 times a negative 1, that's going to be a positive 4. And last but not least, we're going to bring down the 6. So if I do, from left to right, add and subtract, negative 2 plus 4, that's 2. And 2 plus 6, the final answer is 8. Okay? So the vertex y value is 8. So let's go to that most important point, negative 1, 8. So negative 1 on the x, 8, 1, 2, 3, 4, 5, 6, 7, 8 right there. That is my vertex. And since the a value is negative, it's going to be opening down, so I already know that's my max value. I'm also going to draw my axis of symmetry right through it. Okay, and now we need more points, so I'm going to jump to an XY table to get more points. The easiest number to plug in if you haven't already used 0 is 0, right? And when you plug in 0 into a standard form quadratic equation, your output will be the c value, which is 6. So if we go to the coordinate 0, 6, 0 on the x, 1, 2, 3, 4, 5, 6 will be right there. And of course we could map that over to the other side. 1 unit away would be right here. And we need more points, so let's plug in another easy number like the number 1. And if we were to plug in a 1, let's zoom in and do that. Let's plug in a 1 for x. What is 1 squared? It's 1. And what's 1 times negative 2? Negative 2. What's 4 times 1 right here? That's going to be a minus 4 and then a plus 6 at the very end. So negative 2 minus 4, that's negative 6. And negative 6 plus 6 gives you 0. So when I plug in a 1, I actually get out a 0. And let's see where that coordinate's at. 1 on the x, 0 on the y. That's right on the x-axis itself. Put a dot there. Map it over to the other side. 2 units away. 2 units away will be right there. And after that, all we need to do is draw our parabola through those coordinates. Put some arrows on it. And that's it. We're done. However, let's state the domain and range just for kicks. The domain are your x values, and all domains of any parabola is x equals all real numbers. It doesn't matter if it opens up or down. The range values are your y values, and your y values run up and down. So this whole parabola is below a certain y value. What's that certain y value? Positive 8. So y has to be what? Smaller than or equal to 8. So you're going to say y is less than or equal to 8. I hope that makes sense. In addition to that, if you wanted to state your axis of symmetry equation, so the equation of the axis of symmetry will be x, it's going to be x equals the x value of your vertex, which in this case is negative 1. That's your equation of the axis of symmetry. If this quadratic equation, negative 2x squared minus 4x plus 6, if that were equal to 0, and I asked you to solve it, you could also solve by graphing, because the answers to a quadratic equation will be the x-intercepts of that quadratic equation. So we could clearly see here that the parabola will cross the x-axis at the x value of positive 1 and also at the x value of negative 1, 2, negative 3. So ladies and gentlemen, if I were to ask you to solve it, you'd get the two answers, negative 3 and positive 1, if I asked you to solve it. So just for future reference, whenever you graph a parabola, the x-intercepts are technically the answers to your quadratic equation. Okay, so I've stated a lot about this quadratic equation. Is there anything else that we could state that I'm missing? We already stated domain and range. We already stated the axis of symmetry. We stated even the answers to it by looking at the x-intercepts right here and here. What else, guys? That's it? Starts with the M.
Oh, the maximum or minimum?
Yeah, so is this a max or a min?
Max.
Max. Why? Because obviously if it's going up from left to right, goes up, reaches a max height, then comes back down. Now, what is the max value? The max value is negative 1, 8. It's the same coordinate as your vertex. And that's absolutely all there is to state about this parabola.